Step inside a massive commercial aircraft hangar, and you are instantly surrounded by heavy industrial machinery in constant motion. A workplace hazard is anything with the potential to cause harm. When these are mismanaged, the results involve severe physical injuries and lasting emotional trauma for the personnel involved. Beyond the human cost, an accident stops production instantly. The resulting damaged machinery, spiked insurance premiums, and legal fines can threaten a company's financial survival. Technicians operating in this environment face three distinct categories of risk on a daily basis: physical, chemical, and ergonomic. The scale of the aircraft forces you to work at significant heights on scaffolding, while interior maintenance requires crawling into highly confined, oxygen-depleted fuel tanks. This technical breakdown highlights the diverse threats around a single airframe. The red overlays pinpoint specific danger zones, excessive noise, fall hazards, and areas prone to chemical fumes. Because these very dangers overlap during a standard shift, they often become normalized. Identifying them before you act is the mandatory first step in surviving this environment. Workplace safety is strictly governed by law. In the UK, the Health and Safety Executive enforces these standards. The foundation of this oversight is the Health and Safety at Work Act, 1974. This legislation places a heavy and direct legal responsibility on the employer to protect their workforce. Management must carry out continuous risk assessments of the work being performed. They are legally bound to establish safe practices and provide the necessary training to navigate those risks. To proactively evaluate what can go wrong, organizations use a tool called the Job Hazard Analysis. This flowchart maps the process, moving from the hazard itself down through attempts to eliminate it, applying engineering controls, and establishing administrative warnings. A formal analysis is prioritized for tasks with high historical injury rates, or complex jobs where a single error leads to catastrophe. Notice how removing the hazard completely, or installing engineering controls like ventilation, is always the primary goal. Only when those upper layers fail do we rely on the final node, personal protective equipment. Items like respirators and safety harnesses are the absolute last line of defense. Management is legally required to build this protective framework, but it remains ineffective if the workforce fails to engage with it. The legal burden does not rest entirely on the organization. Every individual engineer holds a strict statutory duty of care to protect themselves and their colleagues. You are legally required to follow organizational safety policies. If you see a colleague attempting a dangerous maneuver, you have a professional obligation to intervene. It is an absolute violation to intentionally bypass any safety device provided for your protection. Removing a machine guard on a drill press to speed up a task is a direct breach of this duty. How these rules are followed comes down to organizational culture, the way things are actually done on the floor. Aviation maintenance exists in a constant state of tension between dispatching flights on schedule and maintaining safety standards. When commercial pressure is allowed to dominate, it breeds an environment where impulsiveness, anti-authority attitudes, and dangerous workarounds become the acceptable norm. In contrast, a healthy, just culture ensures technicians feel safe reporting hazards through the company's standard safety management system without fear of retribution. If fear of disciplinary action or peer judgment silences the standard reporting chain, the CHIRP program acts as a confidential safety valve. It is an independent reporting system that scrubs all identifying data, ensuring human factors like fatigue can be addressed without exposing the reporter. Culture dictates behavior. The most advanced safety gear is useless if the dominant attitude on the floor encourages technicians to take shortcuts. Translating that culture to the physical hangar floor starts with environmental safety, which relies on rigorous housekeeping. In a highly active industrial space, a cluttered workspace transforms mundane objects into immediate threats to personnel.
Red targeting circles identify primary trip hazards, uncoiled hoses, and fluid spills. Furthermore, combustible waste like solvent-soaked rags presents a severe fire risk. Finally, environmental safety extends to the aircraft. The last circle highlights unattended toolboxes. Engineers must ensure no hardware is left behind. Debris left on the tarmac constitutes foreign object damage, or FOD. A single forgotten wrench can destroy a jet engine the moment it starts up and ingests the debris. Poor housekeeping is a visible warning of a degraded safety culture, often serving as a precursor to major accidents. The specific hazards of the aircraft require even greater discipline. A modern commercial airliner is a massive machine, generating immense hydraulic, pneumatic, and electrical power. Before testing any system, you must conduct visual clearance checks. Around all movable surfaces, the sudden deployment of a wing flap carries enough mechanical power to cause fatal crushing injuries. These risks are constant. A technician working inside a wheel well will be crushed if a colleague activates the hydraulics from the cockpit without checking the area first. To survive working on these systems, technicians follow strict lockout-tagout or LOTO deactivation procedures. This requires precise execution. You must pull and collar circuit breakers, physically isolate hydraulic valves, and disconnect power sources before beginning work. Deactivation must be clearly communicated. The technician applies a red warning placard directly over the control lever, informing staff the system is completely isolated. Even on the exterior, the aircraft presents systemic threats. The scale of this exposed jet engine conveys the suction risk of an intake, which, along with extreme heat, requires constant awareness. An aircraft is never truly inert during maintenance. Its systems contain massive stored energy that must be strictly isolated to prevent accidental activation during a task. The core reality of aviation maintenance is that it is impossible to eliminate every single hazard. Instead, we have to measure and control them. This is the risk matrix, which is the standard tool used to objectively bring workplace dangers down to acceptable levels. The matrix evaluates two specific variables. On the vertical axis, we measure the likelihood, or probability, of an event occurring. On the horizontal axis, we measure the severity, or consequence, if it does happen. For example, a minor chemical splash lands in the top left zone. It has a high likelihood of occurring, but low severity. Conversely, an aircraft falling off jacks sits in the bottom right zone. It has a low likelihood, but the severity is catastrophic. Safety law does not demand zero risk. It requires organizations to implement strict mitigation strategies, like better tooling and updated procedures, to protect people as far as reasonably practicable. The ultimate goal of safety mitigation is to push these operational risks downward into the green zones of the matrix. This achieves a state known as ALARP, as low as reasonably practicable. Despite rigorous matrices and strong safety cultures, emergencies will eventually bypass protective layers. A severe crushing injury or an uncontrolled fire can occur in seconds. The absolute primary action in any sudden emergency is to remain calm, assess the immediate situation, and ensure you do not become a victim. Panic paralyzes the mind. If a leak of flammable aviation fuel contacts a spark from an unshielded power tool, the hazard transforms into a localized chemical fire in seconds. Actively participating in organizational emergency drills is the only way to build the automatic muscle memory required to override this panic. If a colleague is injured, you must summon professional help immediately. From there, administer first aid only to the extent of your specific training and competence. The goal is not to be a hero. Your responsibility is to prioritize the victim's basic stabilization until paramedics arrive. Management builds the safety framework and provides the protective equipment, but your personal vigilance on the hangar floor is the final, most critical layer of defense that dictates who goes home alive.